Hello, and thank you for joining me. Today we're going to be talking about adding and subtracting fractions. We're going to go through some simplification process and also some problem solving process that kids hit today when we were learning about this. First problem I have here on my paper, as you can see, is 3 4/7 plus 2 1/7. This is possibly one of the most straightforward problems that kids will encounter. So that's why I'm starting here, because it's very, very simple. It's very easy to do, and there's not a whole lot involved here. The first thing we're going to do is start out by adding 4/7 and 1/7. So we're going to work from the right to the left, just like we would if this were whole numbers that we were adding. So starting with 4/7 plus 1/7, our answer will look like this. Below I have written my answer to just the fractional part of this problem. You can see it's 5/7 because 4 plus 1 is 5. Our denominator didn't change because we have the same number of pieces as we started with when we end the problem at the bottom. Students should know this, and if they came out with 5/14 instead of 5/7, that's a problem that they need to be correcting. We've talked about this many, many times in class. As I said before, and I'll say it again, the denominator does not change. Not yet, anyways. After I've added my fractional numbers, I'm going to go ahead and add my two whole numbers, which again, very, very simple, and it's going to look like this. 3 plus 2 equals 5, so my answer to this problem is 5 5/7. There is no simplification that has to happen here, nothing else that I need to do. This is simply the answer to my problem. Moving over to this next problem, still focusing on addition, we have this problem right here. Same process as before. I'm going to add starting on the right side and moving over to the left side. You can see that I've gone ahead and added this problem together, and I came up with 8 6/5. You will notice also, hopefully, that the fractional part of this number is an improper fraction. That means that the numerator, which is this number that's on the top, is bigger than the denominator, which is the number that's on the bottom. And that's a problem. We want to fix that. There are a couple of different ways you can go about fixing that. The first way that I taught students today was to have them draw a picture to show themselves what 6/5 actually means. And then the second way I will show you has just purely to do with numbers. The first way will look like this. So on this piece of paper you can see that I have drawn rectangles. Students can also use circles as well. I chose rectangles because with fifths it's a little bit easier to divide a rectangle into fifths than it is to divide a circle into fifths. In this case I went ahead and shaded in 1, 2, 3, 4, 5, 6, 7, and 8 whole rectangles. And that's because if I go back to my problem over here, you can see that my whole number is 8. Then I'm going to come back over here and I'm going to look. I drew one extra rectangle to represent that fractional number. And I'm going to go ahead and start shading in 6/5 of this piece. When I'm finished, it will look like this. Now you'll notice here I shaded in 5 pieces, but I need to shade in 6. And I don't have 6 in this piece to shade in. So I'm going to have to draw an entire other rectangle and divide it into fifths in order to accomplish this task. Okay, there's my new rectangle, and it is divided into 5 pieces. Over here I shaded in again 1, 2, 3, 4, 5, and I need 6, so I'm going to just shade in one more over here, and that's going to be my 6/5. Now I'm going to look at my picture as a whole, and I am going to decide how many whole entire rectangles I have shaded in. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my whole number is going to be equal to 9. In my fractional piece, which is just this one rectangle that's all by itself, that has just one piece shaded in, you can see I've got 1, so I'm going to write 1 over. And since this piece is still divided into 5 pieces, my denominator is going to be 5. Coming back over here to this paper, you can see then that this is going to equal 9 1/5. So 8 6/5 is the same thing as 9 1/5. Students do need to know how to turn it into this format, however, so it's very, very important that they understand how to use the pictures in order to do that. If a student feels like they are in a place where they don't need to use the pictures and they can kind of mentally understand what these numbers are doing when you have 8 6/5, they can use kind of a mental math strategy in order to make this into a mixed number. Most students will understand that this number is really 8 plus 5/5, which is equal to 1, plus 1/5. And if you add again that 5/5 and that 1/5 together, you would get back to 6/5. Now, since this number right here represents 1, and students have been taught that, we have had this conversation extensively, what they're going to get is that 8 plus 1 is 9, and then they have that fractional piece left over, so they're still going to have to write down that 1/5. If your student is comfortable enough to just pull this number apart mentally this way and come up with this answer, great. I'm totally fine with that. If they can't quite get there, though, I do want to see them drawing pictures so that they can visually understand and represent exactly what it is that's happening when they change this mixed number with an improper fraction involved into a mixed number with a proper fraction. So, coming back to my original problem, 5 and 4/5 plus 3 and 2/5 is 8 and 6/5, and we changed that because 6/5 is an improper fraction into 9 and 1/5, and that's my final answer. Again, I do need to see that this step is involved with your students' work because I need to see that they understand that they had to change their original answer into this new answer, which looks completely different than the first one. Coming over here to my final problem, this is a piece that we haven't gotten a whole lot of time to cover yet, but we will get there, is, again, an addition problem, 2 and 2/6 plus 4 and 2/6. And I'm going to go through my first original steps and add, starting at the right and moving over to the left, these numbers. So I'm going to get 4/6, again, my denominator stays the same, and 2 plus 4 is 6. So my answer is 6 and 4/6. Now, if your student is being aware of the numbers that they're using, they're going to look at 4/6 and they're going to notice that these are two even numbers, and these are numbers that can actually be simplified. The common factor that these two numbers share is 2, because they're both even. In this case, they're relatively small numbers, so they're going to be really easy to deal with. I'm going to divide by 2 up here, but if I divide by 2 on the top, I have to divide by 2 on the bottom also. This is our rule with fractions, is that whatever I do to the top, I also have to do to the bottom. The 6 is going to stay the same. That doesn't get touched because that's our whole number and that doesn't need to be changed. 4 divided by 2 is 2, and 6 divided by 2 is 3. So the actual answer to this problem is 6 and 2/3. If your student is not ready for this kind of simplification, don't worry. It's not going to count off on them right now. What I'm really looking for is the process of adding with fractions. And we will get to this step where we simplify and we work really hard at this as a group, and it'll be later on in this unit. So if they're not there today, don't worry about it.